Greetings! Do you want to enhance your IoT and embedded products with security and high-speed connectivity and take them to market faster? In this video, I'll tell you how. My name is Ashish Ahuja. I'm the product manager for Renesas Advanced Microcontroller Kits. I'm going to show you the new EK-RA6M4 evaluation kit for the RA6M4 microcontrollers. You can use this kit to effortlessly develop cutting-edge IoT and embedded products. We'll talk about the key features of the kit, unbox one, and run the Kickstart example project that is pre-programmed on the kit. Let's open the box and show you what's inside. The kit includes a welcome card, USB host, device, and Ethernet cables, and an EK-RA6M4 board. The board features a 200 MHz ARM Cortex-M33 core-based MCU with enhanced security and rich assortment of high-speed connectivity peripherals. The EK-RA6M4 board is architected to provide standardization and flexibility that helps you shorten the learning curve and frees up your valuable time for differentiated innovation. The board consists of two sections. The first section consists of ecosystem and system control area that is standard across all the boards based on this architecture. This section provides advanced debugging and ecosystem expansion capabilities. The second section is unique to each board. It comprises of special feature access and native MCU pin access areas. You will find superset RA6M4 device and high-speed connectivity interfaces here. So let's get our hands dirty and run the Kickstart example project now. The example project showcases a mini web server, DNS Lookup, and external memory speed comparison. It can serve as an excellent starting point for you to create advanced application. Power up the board through the USB full speed port by connecting it to a host PC. The white power LED lights up. The Kickstart example project begins to execute, flashing the blue user LED. The board uses USB CDC to communicate with the host PC. Open the terminal emulator application such as TerraTerm and connect to the serial port the board is connected to. The welcome screen will appear showing various menu options. The first menu option shows information including the microcontroller die temperature, the user LED intensity and frequency, etc. Press the user buttons S1 and S2 on the board and view these parameters change on the terminal window. You will also notice a 128-bit unique ID. It may be used for key generation in cryptographic applications. Menu options 2 and 3 demonstrate the Ethernet connectivity. We will run a simple web server that shows a platform-independent user interface for remote control and monitoring. We'll also connect to the internet, use DNS Lookup, and ping a web server. Plug in the Ethernet cable connected to the network router on the RJ45 port on the board. Make sure that the board and the PC are connected to the same local network. Press Tab to initiate the connection with the IP network. The board will be assigned an IP address using DHCP running on the router. Open the web browser on the PC. Type the IP address in the address bar and load the client web page. Some of the kit information that you previously viewed on the terminal is now shown on the display console. This demonstrates the communication from the web server to the client. Toggle the software user buttons S1 and S2 in the control panel on the web page to change the frequency and intensity of the blue LED on the board. This demonstrates the communication from the client to the web server. If your router is connected to the internet, we can use the DNS to look up the IP address of a website. Let's go to menu option 3, perform a DNS lookup, and find the IP address of renesas.com. The kit pings the IP address to confirm the connectivity with a web service over the internet. Okay, so that was a lot of connectivity, and there is more. RA6M4 microcontrollers also feature integrated Octospy and Octospy peripherals that use multiple data lines to provide significantly higher throughput than the classical SPI. Menu option 4 performs a quick comparison between read-write times of the onboard quad and Octospy flashes. The data block of the desired size is generated and copied from internal SRAM to external SPI memories, and then it is read back. Looking at the read and write times, it is evident that Octospy provides a considerable performance advantage over quad SPI. The last menu option shows a list of useful resources. Refer to the Quick Start guide to learn more about the example project and for instructions to modify and reprogram it onto the board. The RA6M4 board also features multiple debugging modes that allow you to debug the RA microcontroller on the kit or on your custom board. You can enhance the functionality of the kit and implement a myriad of application use cases by simultaneously connecting multiple third-party add-ons from popular ecosystem. You can also connect a generic prototyping board to the native pin headers to build and test drive your custom circuitry. For more information and to order your own kit, please visit the kit webpage. This is where you can download user manual, quick start guide, additional example projects, schematics, bill of materials, and manufacturing files. So in this video, we talked about the key features of the RA6M4 kit and how you can utilize them to quickly create rich and connected embedded products and take them to market faster. We hope that you enjoy innovating with this kit as much as we have enjoyed developing it. Order one today and bring your big ideas to life.